Okay, so this is a bonus video that I'm putting together for you right now because there's a couple topics in the world of databases that I find incredibly interesting, and one of them is basically how the database writes to the hard disk, or the engine writes to the hard disk, and how that information is pulled out and how it's stored and the effects of it. So we're going to see where this goes. Like I said, I enjoy talking about it. And again, it's one of the situations where I don't have anyone ask me questions, so I will present the information, and then you can ask any questions you have after the fact. Okay, so let me stand up here. Okay, so how does a database engine, how does the Oracle engine write to the disk? So we know, we've got this symbol for the hard disk, and that's what the hard disk looks like, and it's just massive amounts of space and has it right there. So it does organize it somewhat. What it does is there are pieces of the disk it creates, and they're called data blocks. In the world of SQL Server, they're called pages. Okay, and then there are extents. So basically what Oracle does when it creates the table space, it grabs a bunch of data blocks and places in something called an extent. So a data block is 2K in size, okay? And an extent is made up of how many data blocks it is. So if an extent has 24 data blocks in it, it's 48K. If it has 100, it's 200K. So let's just do this. We're gonna draw our extents here in black. And this is just a really generic representation because I want to talk a little bit about how it's written there, and I also want to talk a little bit about how fragmentation occurs. So here's our data blocks, however many there are in here. Okay, so you've created a table and you're putting information into that table, and we're gonna use colors to represent the data. So we're gonna have orange here and red, and I think I got green here. So this is your hard drive. These things are sitting on a hard drive. This is where your data is. So something writes to it. So let's say you're writing the red table, and you start putting the red data in, okay? And what happens is, as the database is writing to disk, it puts it in based on your primary key. Because that's the most important thing in that table. Your primary key is the most important thing in the table because that is the default order on how anything is searched by. So, and you've got your other indexes you can do, your non-clustered indexes that are also, but we're going to just deal with primary keys. And so it writes in there like boom, 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 okay? And then there's a bunch of free space. But then let's say you start writing to the green table. And then what happens is this extent will now, because there's free space there, they'll start putting green data in there. Boom, 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 boom. Green data goes in here, okay? And anytime it runs out of space, it opens up a new extent. Once an extent is full, it's closed, okay? And then a new extent is made with new data blocks and data is written through there, okay? Let me darken up the screen a little bit here so you can see better. Yeah, green, 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 green. Okay. Now, when a query is written, hang on one second, let me close these email notifications on here so you don't see them. Okay. So when these when a query is run against the database, against the tables, what the SQL engine is, I talked about this in one of the previous videos, it looks at your from clause first, okay? So it goes in and grabs everything from the from clause first, okay? And it takes all that information, puts it in memory. How does it organize it? Well, it's organized by the primary key in memory. So let's say you're using from members, right? And let me see. Okay, so it grabs all the members data, and let's say the primary key is member ID, and it grabs all of it by that information and places it into memory, and that's how it's organized down. So for sake of argument, let's say the red table is is memory, members rather, okay? Takes in, sorts it out, does all the massaging there, but it's all based on, and when it pulls it out in order, because this is now a perfectly ordered table in the extent. There's no issues whatsoever with that, okay? Everything's in perfect order. Query comes in, grabs it out, massages it, changes the order, does what it wants to do, gets what it doesn't want, and then, but the point is, here's perfect. Now, tables don't stay perfect for very long. So let's say we start deleting data out of the members table, or the red table. So, and as we delete the data, things come out there, right? We delete a lot of data. And let's say someone creates the orange table, and we get orange data that goes into place. Can you tell between? No, you can't tell the difference between that. So let me not use orange, because orange is difficult to tell from red. Okay, so let's make blue data. So we have the blue data here. Okay, so all of a sudden blue data starts popping up, and this is starting to look like a little bit of a mess. Now let's say there's more red data to be written. So where's the red data going to go? There's nothing here to go, so red data starts getting written over here. Okay, so all of a sudden red data is here and red data is here, and let's say more blue data gets written over here, and then more green data gets written over here. So, see those colors? Yeah, see those colors. So this is what we call fragmentation, because the information is no longer in any kind of order over here. Now, what happens is, so let's look at it this way. Let's look a little differently here. So let's say each of these data blocks is one row of data. It's not necessarily, let's just say it's one row of data. So this used to be, let me draw another one here. When this was all red data, it was like row 1, row 2, row 3, row 4, row 5, row 6, 7, 8, so on and so forth, okay? Now, here's row 1, here's row 3, here's 4, here's 6, here's 7, 8, 9, 10, here's 10, and here's 11, and then over here are 12, 13, 14, so on and so forth. Here's row 1, 2, 3, 4. So you kind of get the picture here, right? Let me get my eraser and blow this up a little bit more for you here, so you get an idea of what's going on here. I should have drawn these bigger to begin with, so let's go. Okay. So here we go. And like I said, I keep these informal lessons on how I would do them in reality, so will have me doing a lot of drawing and redrawing. So let's just keep the one table in that table here. Do the same thing. There are data blocks in our extents. Okay. Okay, let's darken these lines up a little bit so you can see better. Okay. So again, remember when we started talking? We had the red table, the blue table, and the green table. So on our initial loads, the red table wrote row 1, row 2, row 3, row 4, row 5, 6, 7, 8. And then the green table wrote some rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, my green marker is not doing so good here. Let's see if this one's doing any better. Okay, so you kind of see there, okay? They're bigger, so you can send the numbers. Now, this is our initial load. Everything's in order. Everything's great. 1 through 8, 1 through 14. A lot of empty space over here. But now we're going to get rid of some green data. So we're going to say, we're going to write row 2, row 7, row 10, row 12, and row 13. So we got this, and we're going to get rid of like row 2 here and row 7 here. So we did a little bit of data purge, okay? Maybe some of our inventory got sold out. We don't have an inventory anymore, whatever reason. Some of the red data, some of the green data got purged. So now this is now open space in the extent. It doesn't stay open. It stays open until something gets filled in there. And the database will just put whatever it wants there. The next thing that goes in, so the blue table comes in and say, okay, row 1's going to go here, row 2's going to go here, row 3, row 4, row 5, 6, 7, 8. So this is getting started a little messy, okay? And then, oh wait, there's more red data coming in. So red data is going to go here. Here's row 9 is going to go here. And then 10, 11, 12, 13. And then green data there's more green data coming in. 14, 15, 16, 17, and then more blue data. 9, 10, 11, and then some black data pops up out of nowhere because someone added a new table over in accounting. So all of a sudden, these nice, clean, solid extents we had are now mixed up, and they're called mixed extents because there's no longer a cohesive day. And when the query wants to go, you want to query that red data, right? The query's got to go and say, okay, here's red data, here's red, and starts having to look for this stuff because the indexes are pointing everywhere. The indexes are no longer cohesive either because the data is everywhere. Because whenever you add something new to it, you pop it at the end or into an open space here. I don't know if I've always equated this like collecting comic books or collecting baseball cards or anything that has an order to it. So you buy 15 issues of your favorite magazine or comic book and you put them in order, right? And then you trade out a couple issues so they're missing in the run, and then you buy more issues and they go in the back. So instead of putting things in the order they belong in, you add them to the back of the box, wherever you're holding it in. So that's what happens here. Whenever data gets deleted from a database, from an extent or whatever I say, it gets placed in, it gets the big hole of the data is in there, and the next time something gets input into that table, it takes up the spot that was open. So here, this was a solid red, this was solid green. Now I've got red, blue, red, red, and then green and blue. It's mixed all over the place. Okay, this is where fragmentation occurs. Fragmentation occurs when the data is no longer stored in a cohesive order, and the indexes can no longer function properly because information is towards the back. So let's look at this a slightly different way, which will make a little bit more sense here. So instead of looking at primary keys, we're going to look at, make this look a little differently. Okay. Let's say you had an index on last name, red, blue, green. Okay, so let's actually make it easier because first name. Let's say an index on first names. Okay, so you have Al, you have Art, you've got Bob, you got Chad, you got Dan, Frank, George, and Harry. And then your green data, you're going by first name too, and we got Abe, and then we got Bill, and then Ben, and then Bill, and then Chris, and then Kurt, and then in the blue data, let's go black data here. We've got Ed, and then Frank, 2 Franks, and then we got another Gary, and then we got Glenn, and then we got Roger, and Xavier and Zach. Okay. So these are alphabetically set, but we delete some data, and then we get rid of that, and we get rid of Gary here, and Bill, and Ed over here, and then Zach and Xavier. Okay. And we get rid of Frank. So we delete these people out of the database. So now this is when we have the green data coming in. No, we got the green data. Let's go. We got red data coming in. Another color here. No, so we have new black data coming in, and so now we got Archie. He's here, and then next one we got is William. And then red data comes back in, and red data brings in Steve, and then brings in a guy named Serge. And then the green data brings in Donna and Rose and Martha. And you can't read those names, but they're there. The screen isn't working so good. Let's try this one here. Donna, Rose. Okay, just give it. It's Rose and Martha. So now again, just another way to look at it, that the data is now out of order. Okay. Okay. And so when it's trying to search, the first thing the query does, it pulls all the information from the data, the table, into memory. So now what it's going to do is it's going to pull everything out as is. So if you pull the red table out, and you're going to get like, it's going to go Al, Bob, Chad, Dan, Steve, Harry, Serge. So it's no longer in order. So the index is going to have to go, okay, wait a second, guys. Bring that stuff out. Let me order it, and then you're good. So you're thinking not a big deal, but if you're doing this with like 15 million rows, and you're pulling all that information into memory, and it's not in any order because the indexes are fragmented because data has been rewritten and rewritten and rewritten, that's where the problem starts, okay? So in Oracle, there's two things you can do. You can rebuild indexes, or you can delete unused space. So what that means is, for like when this was on, let's go back to this model here. So red, 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 green, 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 black, black, black. So if you deleted the unused space on this table, what it would do is it would take everything and shift it, and then delete all the unused space. So so instead of looking like this, it would suddenly look like, green would be here, black would be here, and then you're condensing your space and getting rid of it. So this is good because it's a fast, nerdy way of doing it. You don't have all this excess space that the query actually has to go through, make sure that's empty. But it still doesn't put things in order, okay? And I'm not going to get into the commands on how to do this because that is beyond the scope of this class, but I just kind of I think it's important that you understand what goes on under the covers here in the database engine, so you can better understand why indexes get written, how they get written, and when queries start to slow down, this is why they slow down. So let's look at this table here, and we're gonna defrag it over here. Okay. So we've got a fragmented table. The indexes are blown because we keep adding data and adding data and adding data and deleting data and adding data and deleting data and adding data. So all of a sudden my table is no longer in any kind of order. My indexes are all shot because everything gets put in at the end. Nothing gets put in where it back belongs. It's not going to say, okay, here's A, here's B. So something between A, L, and B has got to go here. It doesn't work that way. It just drops whatever there. It doesn't sort on the insert because it doesn't care. So the command to rebuild indexes, what it basically does, it takes all the information in the table, builds it into the order of the primary key, and then puts it back in the table. So this table here, what would happen if I re-indexed it, let's see. It would go Al, Bob, Chad, Dan, Serge, no, Dan, sorry, Harry, Serge, and then Steve. And then my green data would go, I'm going to change my green data to blue data because my green markers just don't want to live anymore. Abe, Ben, Chris, Kurt. Oh, my lights went out. Hang on. All right, sorry about that. Chris, Kurt, Donna, Rose. So you get the idea. So it takes all the data from that index, the index on the red table, pulls it out, sorts it into the order of the primary key, and then puts back in the table in order. And it cleans up, which makes searching easy again because now the query, everything comes back out in order. We don't have to reapply anything. We don't have to get the indexes working. And again, we only have like 9 things here. That's like that, right? But look in terms of like millions, hundreds of millions, hundreds of thousands of rows, this becomes a huge issue. So, so that's why you got to watch on fragmentation. So a couple things about index fragmentation. First of all, indexes built on tables. So when you do a query off of a table, like I said, it grabs the information from the table, puts it into the memory, and then applies the index to it. So it's sorted. So now if you've got a primary key index and a clustered index, it does the primary key index first, and then applies a clustered index over that. So that would mean like if your primary key was member ID, and the non-clustered index was last name, it was sorted by primary key, and then it sorts by last name attached to the primary key. So now when you're doing a search on last name, it will go find the last name and then get the primary key and then look for the rest of the information on the table. Okay, that's how this works. Everything's based off the primary key. So even when you're doing a search on a secondary index or a non-clustered index, it's still search off the clustered index. So lost my train of thought there. Let me get this clustered index. So yeah. So that's why it's so important to keep this stuff in order and defragment. So rows that have less than 200,000 rows. So back up a second. When you do a query on a table that does not have an index, it performs something called a table scan. So if you've got a table called members that has 1 million rows in it and you're searching for someone's last name, basically what the query is going to do is pull all that stuff into memory, and then it's going to go one by one, R-bar, row by agonizing row, Stanley no, Stanley no, Stanley no, Stanley no, Stanley no, Stanley, until it finds ones, and it's going to take one off to the side, take it off to this side, take it off the side, and then keep the data over there that it's looking for. But there was no index to find it fast, right? So if you're looking for the last name Stanley in a members table, if you're indexed, boom, here's the Stanleys, put them over there, one easy scoop and done. But if there's no index, it performs a table scan and goes row by agonizing row through each row to find the Stanleys. If you have less than about 200,000 rows, it does a table scan anyway. Indexes don't matter. It will still do a table scan no matter what happens because it's a very, 200,000 rows is a very small amount of data in the world of data. Anything over 200, and these are just rough numbers. Anything over 200,000, it will apply the index right away. Fragmentation. Fragmentation always comes in a percent. Anything under 15% does not affect performance badly. It still affects performance, but under 15% is not that big of a deal. I thought I turned this off. Okay. Apparently I didn't, I guess. Okay, so we want to keep fragmentation underneath 15%. Over 15%, we want to rebuild those indexes. We have to rebuild the indexes overnight. We can't do it during the day because what happens is, like I said, it's restructuring the entire table, and users can't be in that table while it's being restarted. It's like if we were going to renovate your house and rebuild everything, you couldn't live there while we were doing it. You have to get out of the house, live somewhere else for a while, make the changes, come back in. Same thing's true with indexing. Can't do it while you're there. You have to leave the house, come back, it's done, you move back in, bring all your stuff. Make sure it stays in order, okay? So yeah. So that's kind of what I want to talk to you guys today about just how data is organized, how it gets put into the database, mostly about the database block, the data box and the extents, and how this is kind of a visual representation of defragmentation. As you guys go along in your DBA careers, in your DBA learning, when you get beyond this class, you're going to learn about indexes and fragmentations and how indexes work, or why you put them where they are. But this will give you a good fundamental understanding of why indexes exist. Because indexes put the data in order when it goes into the table based on the free space. And then when it rebuilds the indexes, or let me just get the lights over here. When it rebuilds the indexes or it reorganizes the indexes, it puts them in the order of the index so it's easier to search. Standard rule of thumb, I'm going to go into the standard rule of thumb of indexes when you're creating them. Right now, you guys have just created primary keys. You haven't gotten to any other indexes, and there's primary keys, which are referred to as clustered indexes, and you've got non-clustered indexes, which are anything other than the primary key. Anything that is an aware clause should be a non-clustered index, because that is something you're searching on. So if you're doing select star from members where last name equals Jones, you need a non-clustered index on the last name. So when it pulls everything back, it'll find all the Joneses really fast because they're all clustered together off to the side. Okay. So I hope this makes sense. I hope this is just a quick, fast and dirty insight into how indexes are built, how indexes work, how fragmentation exists. There is a much deeper conversation to be had here. If you're interested or have more questions, please reach out to me. I love deep dive stuff. We can talk about it through Hangouts or emails or anything like that. I'm happy to help you guys understand this better. But I just want to give you guys like the previous one about how queries work and how selects work and how that works. I just want to give you a quick idea on how the storage system works underneath the database. So how things are put away, stored, and organized, and why fragmentation occurs. All right, so that ends it for this lesson. If there's anything else you guys want to talk about, any topics that are interest of you that that aren't covered in the labs, please let me know. I'd be happy to make a quick video for them so you guys can get basic understanding. Again, I'm not going to do like a whole lot of deep diving and like how to create non-clustered indexes and how to actually defragment, because that's beyond the scope of this class. But I think as you're understanding the fundamentals of database design, understanding the fundamentals of table design, it's important to understand how the stuff gets stored on the back end, because how the stuff gets stored on the back end affects how you do things on the front end, how you create the tables and why you create the tables and how you create the indexes, and why you create the indexes. You don't want to create too many. You want to create too many indexes. You don't want to create too few indexes. Could you imagine a table with 15 columns that has 25 indexes on it? I've seen it. It's ugly, because the other thing about indexes, keep in mind, is that indexes increase the space of your table because they take up space. They're physical things. They're not like views. They actually exist. And when you refragment, they drops them and recreates them. So I hope this makes sense. I hope this made sense to you. And again, if it didn't, please ask me questions. I'm still looking for a time for everybody to meet as a group and kind of do this. Hopefully next week we'll figure something out. Okay, thank you guys, and I hope you have a great rest of your day.